Today's notes will cover in class 18, which is going to talk about different criteria for proving that triangles are congruent. So if we think back to our discussion earlier about congruent polygons, we can think about what the definition of congruent triangles would need to look like. We would need 3 different pairs of congruent corresponding sides, and then we would also need 3 different pairs of congruent corresponding angles. And the reason that we would need this is because every side would need to have a congruent corresponding part. So that would be one set, this would be a second set, and then this would be a third set to make sure that each of those sides had a congruent corresponding part. But also, according to the definition of congruent polygons, all of the corresponding angles would also need to have a congruent corresponding part. And so that means that there's a lot of information for us to check for if we're going to use the definition of congruent polygons or the definition of congruent triangles to explain why 2 figures are congruent to each other. So what we're doing today is we're trying to look for smaller amounts of information that would give us the same result. And it turns out that there are 5 different ways that we can use less information than this, but still guarantee that the triangles that we're looking at are going to be exactly congruent to each other. Now, this video won't go into the why for each one of these work, but if you are interested in that, we can provide some additional resources that will explain why each one of these things actually does force our triangles to be congruent, even though we won't be focusing on all 3 pairs of congruent sides and all 3 pairs of congruent angles. So the first option that we have available is something that's called Sss Postulate. Those S's stand for the word side. So when your teachers read this, you might hear them say side, 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 postulate. And so what that means is instead of focusing on the 3 pairs of congruent corresponding sides and the angles, we can just focus on the 3 pairs of congruent corresponding sides. So if we see a situation where there is a match for each and every side of the triangle, then that's going to force the angles to automatically be matched as well. And so only seeing those 3 pairs of congruent corresponding sides is going to be enough for us to be able to say that this triangle is congruent to this triangle. The second option, is going to be called Sas Postulate. So those S's still stand for side. The A stands for angle. So if we read that out loud, we'll say side, angle, side, postulate. So for this one, we're going to need 2 pairs of congruent corresponding sides, and then only 1 pair of congruent corresponding but included angles. Included describes the location of the angles. That A is sandwiched in between the S's, and that's important because if the A wasn't in the middle, it wouldn't be side, angle, side anymore. It would be something different. And so what we're looking for in order to spot this particular way of showing that triangles are congruent is going to be 2 pairs of congruent corresponding sides. So that would be 1 set of congruent corresponding sides. Maybe this is the other one that we know. So that's now 2 pairs of congruent corresponding sides. But then what needs to happen is that if we are to highlight those sides as being corresponding, and then these sides as being corresponding, the angle location needs to be where those side pairs come together. And so the angle would have to be right here in that triangle in order to be included, sandwiched in between the sides, and it would need to be right here in that triangle in order to be included and sandwiched in between those sides. So that would be an example of what side, angle, side postulate looks like. For the third option, the S's and the A's disappear, and we end up with H and L instead. So for HL, we've got something completely different going on. We are going to need 1 pair of congruent corresponding hypotenuses, that's what the H stands for, and then we're going to need one pair of congruent corresponding legs. That's what the L stands for. But in order for a hypotenuse to even exist in a triangle, it has to be a specific type of triangle. A hypotenuse only exists if we're dealing with a right triangle. So this stands for HL, Hypotenuse Leg Theorem. So in order to know that something's a right triangle, we're usually going to have a right angle box present somewhere. We could also have a 90-degree label marked, but usually it's the right angle box. Just some vocabulary to make sure we understand. The H, the hypotenuse, is always going to be the side that's across from the right angle. So we would need to know that those two hypotenuse sides, the ones across from the right angle, are congruent to each other. That gives us the H. And then the L, which stands for leg, could be either of the sides that make the right angle, the ones that make the L. So we don't need to know both of them. We just need to know that one of those sides that makes the right angle in that triangle is congruent to one of the sides that makes the right angle in that other triangle. So that's what HL would look like. You need the hypotenuses across from the right angles to be congruent, and then you need one of the side pairs that actually makes the right angle to be congruent. All right, there are two more. ASA is next. So we're back to using A for angle and S for side. So this is an abbreviation for angle, side, angle. That means that we need two pairs of congruent corresponding angles this time, with one pair of congruent and corresponding included sides. Included because now that S is in the middle, sandwiched in between the two angles. So first off, let's mark our two pairs of corresponding angles. So that might happen here with that top angle being congruent to here, that bottom angle. That would be one set of corresponding congruent angles. And then let's go with this angle here also being congruent to this angle there. That would be our second pair of congruent corresponding angles. So then what needs to happen is that we need to also have information about the included side. So if I think about the included side, I need to make sure that it is connected to both of these angles. In other words, it needs to be this side right here that connects the angle with the single arc to the one with the double. Same thing in the other triangle. It needs to connect the angle with the single arc to the angle with the double arc. That's what it looks like for a side to be included between the two angles that we also know are congruent. So that is angle, side, angle, angle, side, angle. All right, our final example here is going to be angle, angle, side. Two A's next to each other, followed by the S at the end. So we're still dealing with two pairs of congruent corresponding angles, just like we were with the previous criteria. We're still dealing with one pair of congruent corresponding sides, but now the sides are not included. That side is only going to connect to one of our congruent angle pairs, not be in between both of them. So if I'm starting by marking my congruent angles, maybe we know that this angle is congruent to this one. That would be one set of congruent angles. Maybe we know this angle is congruent to this angle. That would be our second set of congruent angles. And then I would need to choose either this side here that's connected to the double tick to be congruent to this one, that double arc, or I could choose this side here that's connected to the single arc angle, this one here that's connected to the single arc angle, but I would not be able to use this side because that would be connected and included between both of the congruent angles. Same thing with this side here. That would be the included side. So if I knew that side, it would be an angle side angle problem, not angle angle side. So I could mark the purple ones or the yellow ones. I'm going to choose the purple ones. In either case, it would have been angle angle side. Angle angle side.